video will cover section 4.1, which is angles in radian measure. We're going to be talking about different types of angles, positive angles, negative angles, and then we're going to talk about two units to measure angles. One of them is degrees, you are already familiar with it, and the other one will be radians. So first of all, we have the definition of an angle coming from the book, and so an angle is formed by two rays that have a common endpoint. And so I have here a little drawing of it. So this is the endpoint, one ray, the other ray, and if you put them together, what's in between, that will be the angle. We have another illustration here, and so we're going to call, and this is what I wrote down with blue here. So every angle will have an initial side, which is here, initial, and a terminal side. Initial and terminal side. And all those terms are very important. We're going to be using them during the whole semester. We also have the vertex of the angle. And that's it. That's just an angle. Now, something very important. So if you have a highlighter, please highlight it. Standard position. So for an angle to be in standard position, it has to satisfy two conditions. First, we need to have the vertex at the origin. And I'm going to continue asking you throughout the day and throughout the semester. Standard position, standard position. So the vertex will be at the origin, just like the one you see here, the origin where the x and y intersect. And then also, we have to make sure that for an angle to be in standard position, the initial side is actually the positive x-axis. So right here, positive x-axis. Continue. All right, so we do have two types of angles, positive and negative. And so what we have here is that they're both in standard position. So as you can see, the vertex is there at the origin, and then they both have the same initial side. However, the positive angle is going to run counterclockwise. That means the opposite of the clock. And so it will go in this direction. Well, of course, this one ends here. So initial side, and then counterclockwise, and here we have terminal side. Okay, that will be positive. For a negative angle, that's going to be same standard position, vertex at the origin, x-axis, positive x-axis is the initial side, and so the terminal side is there, but if you notice, this one runs in the same direction as the clock, so we call it clockwise. So imagine the hands of the clock, they go in this direction, right? Yes? Same as this. Okay. And what are these little tiny letters here? Do you guys know their names?
Theta and alpha.
Very good. Alpha. Okay. So next slide. All right. So to measure angles, I believe you know this since elementary. You know that they are acute angles, right? And those go from 0 to 90. So theta is less than 0, but, I'm sorry, greater than 0, but less than 90. And if we have an angle that is exactly at 90 degrees, we call it right angle or straight, no, not straight, I'm sorry, just right angle. What is another name for that?
Corner.
90 degrees, right angle. I feel like I'm forgetting a name. Okay, maybe it will come back. And then, of course, we have obtuse. Oh, well, one more thing. If you have an angle like that, can you assume it's 90?
No.
Never. Unless you see the little box, or unless it is written there that it's 90 degrees. Okay, don't ever assume it's 90. And then, of course, we have obtuse angle, and that one is greater than 90. We know that. but it's also less than 180, because if we get to 180, it changes its name, right? So the one that is exactly 180, that will be the straight angle. All right, so we already covered how, and I'm glad you guys know that that symbol is called theta. The one that looks like a 0 with a belt, theta, okay? The one that looks like a fancy V, beta. And these are Greek letters. Some Greek letters are used in capital, uppercase, or lowercase. So this too will be uppercase. This one is lowercase for alpha. This one is uppercase for delta. Do you guys remember that? Change, like the slope, the little triangle, it means change. And then the lowercase delta, it looks like this, like that, like an S, and then like with a little belly. There's another, well, there are several others, like, well, in a minute it will come this one, gamma. Not in this course, but in calculus, you'll see epsilon. Do you guys know of another one? I think that, well, I mean, there are tons of them, but those are the ones that we will be using most of the time. Okay, so if you have an angle, you could read it as theta equals 60, or you could say an angle of 60 degrees, or you could say 60-degree angle. All three statements are equivalent. Or actually, you could say an angle whose measure is 60. So all four statements are equivalent. That's all you need to know from that. And then another thing, I noticed some of you, when you want to give me an answer that equals 0, you tend to do this, some of you. And that is incorrect. Why? Because that is the symbol for empty set. So that means that there's no answer. The answer is not 0. The answer is just not there. So another way to describe that, an empty set, do you guys remember curly brackets? Like when we used to ask, what's the domain? And then you will say, list all the numbers or the order pairs or whatever, if that was a function. So that, just leaving it empty like that, that is equivalent to this. So that means no answer. So if you want to say your answer is 0, don't use this anymore, okay? That's a no-no. They don't have the same meaning. Okay, next slide. So let me have you guys copy that. And then we're going to do a little demonstration. So just like we can measure length and, I don't know, we have several units, miles, kilometers, feet, blah, blah, blah. For degrees, for angles, we have degrees. That's one unit of measure. But we also have radians. And if you were here like the last week of school, I kind of gave a little brief explanation of how to convert degrees to radians. But let's see what's a radian. And it says that the radian is the measure of the central angle. So central angle, if you have taken geometry, or you're taking it concurrently, I don't think you are there yet, because it's second semester when you study circles. So a central angle is going to be an angle whose vertex is at the center of the circle. That's why we call it central angle. And so that's a central angle right there. Right? Regina, pay attention over here. And so what it says there is that the radian is going to be the arc, this arc intercepted. This is the arc length. It's going to be equal to what the radius was. So if I was using the circle, this radius from here to here, if I was to curve it, it should be the same as this one here. So let's see if it's true. So Christopher, come here. So you guys see, I already have one there, but I don't want to make you guys think that it's not true. So we're going to do another one. Actually, this is good. So with the tape, so here with my previous class, we already taped one of the radians. So this length of the string was equivalent to this radius of the circle. Okay, I'm going to pause the video while we finish this. Okay, so what my first period did, we were able to only cut the length here, and then we taped it on the dry erase board, so we have it like that. Then after you do that, if you do it again, you get two of those, right? The radius, but as an arc length. And then if you get a third one, what would that be? 3 radians. So it just means that you took the radius and you stretched it.
Teacher, pardon the interruption.
Okay, guys, do you remember? If you don't, it's okay. Before the end of the semester, we went over how 180 degrees was equal to what? Do you guys remember I told you that was a real pi? That's a real pi. And what does pi like approximately equal? 3.14159 blah blah blah, right? So if we have 3 radians, we are actually that little piece right here, from here to here, that is that 0.14159 blah blah blah. Yeah. So we didn't measure. It might be half of that. And I'll tell you with certainty what it is. Okay. But you guys see what a radian is for sure, right?
Yes.
Okay.
How do you?
All right. So now there is a way to find one of the things that we're going to learn here, and you guys will have a chance to do the fun activity. We're all going to go outside, and you're all going to be horses. What? Horses. Like from a carousel. From a carousel. You guys been on it? Yeah?
Yeah.
Yeah. Because we're going to go over a thing called angular velocity. If you have taken physics, you might know what I'm talking about. So there's a thing called linear velocity, and there's a thing called angular velocity. All right? So before we get to that, we need to build up some skills. So that will be how to find the radian measure when you are given the arc length. So S, we're going to use S for arc length. And we're going to use R for radius, of course. And in this case, theta will be representing the central angle. Remember, central angle, the vertex is at the center of the circle. That's why we call it central angle. Okay, so this is a pretty easy problem, but this is just to build up your skills, okay, so when we get to the angular velocity. So let's see. At central angle theta in a circle of a radius 6 inches, so let's do a quantitative analysis. So we analyze each quantity. The radius is 6 inches. And the arc length is 15. So S, remember that we're using that for arc length, 15 inches. So what is the radian measure of theta? So if we want to find theta, then that will just be S over R, which in our case will be 15 inches over 6 inches. The units cancel. And so the answer is just 15 over 6 radians. Or if someone has a calculator, can you give me a decimal approximation even with your phone?
2.5.
Oh, that's true. We should have known that.
Okay.
2.5 radians. There we go. Okay, now this formula could be used, like for example, if you have theta and you have the arc length and you want to find the radius, how would you do that? How can we solve for R?
Multiply theta times.
R. And then, so that would be like if we wanted to find S, right? We could also do that. And then if we want to solve for R, what do I do? Divide by theta, correct. So write out those three variations. We're going to do that in a minute. I like to take my time with this first section. Some professors at EPCC, they skip it because they think it's too easy. But I actually think that if you don't understand the first section, you're not going to understand the whole course. So I like to take my time with this one. All right, so next one. So don't worry if this is too easy for you. I will get more interested. Okay, so now the relationship between degrees and radians. Let's see. So you already know that to find the circumference, right, like the perimeter of a circle, that we call it circumference of a circle, not the area, what is the formula for that? For circumference?
2 pi r? Yes.
2 pi r. Right. Or we say sometimes pi times diameter, right?
Yes.
Either way. So if I tell you of a whole circle, like a whole circle, the arc length of the circumference, we're going to use this, 2 pi r. Right here for the arc length, in here, 2 pi r. And then all we're doing is using the previous formula, this one. And then we divide by the radius. We don't really know what the radius is. So what can I do with the arcs? They equal 1, so they cancel. So the answer is 2 pi. So what is the angle of the whole circle? In radians, it's 2 pi. You all know what it is in degrees, right? What is it in degrees? 360, yeah, come on, guys.
360.
360 degrees, or 2 pi radians. However, this is very important, and actually I forgot to tell my other class, but I didn't finish this section, so it's okay. You can only use this formula, actually all these three. The angle must be in radians. And actually, you will have a question like this in the test. I always put one of those. They're very, very easy, but sometimes I give you the angle, and then that's more likely what will happen. I'll give you the angle in degrees to confuse you, of course. And then you have to give me the arc length. So even if you know how to do it, like if you don't convert to radians, then you get it wrong. Okay, so anyways, we already know that the whole circle is 2 pi. So what will be half of a circle? You know half of a circle is 180 degrees, right? Or pi radians, very good. So if those two are equivalent, we can use the unit conversion factors. Here. and here. Unit conversion factor. Yeah, are we okay with that? Okay, so let's go to the next one. Why do we call this unit conversion factor?
Because that's how you convert the units to another.
But what about unit? What does that mean?
It's a measurement. Or
What do you guys understand by like, well,
That's how you identify the
yeah,
what
that's
kind of
how you,
measurement you use.
yes. But why can we say that that is true though?
it's proven on the,
Well, we already proved that they're equal, right?
yeah,
So what do you get if you divide something by the same something?
it's
One.
one.
You get 1. So that's why we call it unit conversion, because they equal 1. All right. So let's convert those. And so we have two options, of course, the one with pi on top and the one with pi or on the bottom. So what do we want to accomplish here? Do we want to go from degrees to radians? So do we want to have pi or not? If it's radians. Yes. So we have to keep pi on top. So it will be 30 degrees. Remember, this is divided by 1 because it's an integer. Multiplied by the unit conversion factor, number 1 or number 2? Number 1, because we want pi to stay on top. Here, the degrees, the units cancel. And so we have 30 pi over 1. I'm sorry, over 180. And then we divide, because we always simplify, so it will be. Well, divide bigger. Divide 30 by 30 is 1, so 1 pi. And then 180 divided by 30 is 6. So pi over 6, yes. 6 pi will be like way bigger.
It'd be the other. Oh no.
This will that always be 180?
Yes, this will always be the conversion factor that we will use. Always, always, always. Because remember, and if you forget what numbers they were, think about it. The whole term is 2 pi, because it comes from the circumference formula, 2 pi r. 360 is 2 pi, so if you want to use 360 and 2 pi, that's the same. It will be the same.
Wait, so that can be considered a radian even though it's in fraction?
Which one?
Pi over 6?
Yes, and actually, my bad, the units for radians, they come from here. Radian. Was that what you were going to answer?
Yeah.
That's where the units come from. Okay, now the next one, pretty simple, right? 90 degrees. We use the same unit conversion factor because we want to have pi on top. So that will be 90 pi radians divided by 180. Remember, the degrees cancel. So that's pi over 2 radians. Now, if you have an angle that is negative, like this one, I'm just going to solve it up here. We use the same unit conversion factor, and yes, our radians will still be negative. So this is negative 135 pi over 180. And then I forgot what that reduced to. Any help?
Oh wait, I'm only
Hold up.
gonna decimal point.
Okay, we divide by, what can we divide by? Can we divide by
We
9?
divide by 5.
We can divide by 9.
5.
By 9, right?
Wait. Yes. Yeah, you can. That'd be 15.
And then we can divide by 5, so that will be negative 3 pi over 4.
15.
Yeah, it's okay. But it's, if you notice, it's still
Negative.
negative, yes. Okay, so let's go to your break, and then when you guys come back, you're gonna convert the other way.
Let's go.
So now we're gonna convert the other way from radians to degrees. And we are going to use the unit conversion factor that has pi on the bottom because we want to be able to cancel the pi that we have here on top. So if we do that, I'll do it the long way first, you can see. So this will be, we multiply horizontally, so 180 times pi, and then here we will have 3 pi. So what happens with pi divided by pi is equal to 1, so we say they cancel. And so the answer is 180 divided by 3,
60.
and that is 60. Very good. Yep. Okay, let's do the next one. And the next one is negative. So negative 5 pi over 3. Remember, you want the unit conversion factor that has pi on the opposite side so that they can cancel nicely. And if you forget what number goes there, just remember a complete pi is 180 degrees. Oh, I need to show you guys a picture. Okay, so we cancel pi, and then we have still negative 5 times 180. I mean, you can multiply them if you want. Or you could say 180 divided by 3, that would be 60. So negative 5 times 60 is negative 300. Or you could just multiply 180 times 5, that would give you what? 100, what? 900?
Well, 950.
Okay, and then divided by 3. All right, and the last one, we have 1 radian. What unit conversion factor should I use?
Oh, conversion method.
So we're going to use the same that we used here. 180 and then pi radians here. So if we multiply the radians, the units will cancel. That's what I should have done. And we will have 180 degrees divided by 91. Pi. So what is pi approximately?
Isn't that equal?
3. Well, yes, that's what we were thinking last period, that would just equal to 1. But here we're going to look at it as a number. So let's actually do the division, perform the division. So 180 divided by 3.14 radians. Well, the radians already canceled. So what do you guys get? You can use your phone calculator.
I thought you said we had to put that into it.
Oh, that's true. You guys listen so well. Wow.
What?
We can, yeah.
57.32. So we know about that that is an acute angle, right? Less than 60. If you guys look at my drawing here on the board, from here to here, that's 1 radian. Does that look like about 57 degrees?
Yeah.
Yeah, actually it does. That would be 90, and then 60 is like right there. It's a little bit less than 60. Okay? So 1 radian is 57.32, so less than 60 degrees. Remember, what about 3 radians? Let's convert that. So it will be 180 times 3. And then you divide by 3.14. You could use your calculator, you know. Jamie, you got a calculator. Your Apple Watch has a calculator too?
I'm checking.
Is that the 2 or 3?
2.
I'm thinking about, instead of upgrading my cell phone, just getting the Apple Watch.
Nice.
I just don't like that the newest iPhones don't have the headphone jack.
Oh, yeah.
I just don't like it. I like options.
The adapter.
And then if you want to use headphones and charge it, you have to get that adapter. Okay.
Did you just get
I got
a
171.
6S Plus? That's what I have. I didn't want to get like the 7 or 8.
Yeah, I have the 6S.
Oh.
But not Plus, the 6S.
You should get the Plus. It's the case. Because once you get a case, it's just
But I have the one with the most memory. Okay, so what would that be?
I got 171.
171.97. Thank you, Jalisa. And so if you guys look over here, when Chris and I were drawing those radians, that was 1 radian, another radian, and then another radian, so 3 radians. See, so a little less than 180. So we were on the right track. Okay, beautiful. All right, now, does anyone have like some sort of circular object you could use, like a quarter?
I got a penny.
That might be too small. You could use pesos if you want to. That's okay. Someone had like a 10 pesos coin. It's like the same size as the quarter.
Really?
Yeah. Who has the money?
Oh, I have. I can use my watch.
You can use your watch. Okay, so what you're going to do, guys, I need your attention.
Going outside.
Not yet. You're going to draw 4 circles here.
Oh, like small circles?
So draw your 4 circles, and then you're going to trace the XY axis. Okay, so, well, I'll wait for you guys to do that. We're going to label the circles in different ways, and then we're going to put them all together, and they're going to look just like, one more, no, like that. Ooh. Okay, and I did a little explanation of this, so let's do it again before the break. So we start at 0 degrees, or 0 radians. Let's just do it in radians. And so right here, we already know that this is going to be pi over 2. So if you notice that if we count by halves, that will be 1/2, then here will be 2/2, or 2 pi over 2, which reduces to pi. Very good. And then we have here 2 pi over 2, so this will be 3 pi over 2. And that one cannot reduce anymore. So it just stays like that. 3 pi over 2. Okay, now the next one, I want you guys to cut them and cut each quadrant in half. Like that. So now each pi, remember pi is half of a circle, each pi is divided in how many pieces? 4, yes, 4. So we start here with 0, and then pi over 4, and then 2 pi over 4. Don't reduce yet, we'll do it in a minute. 2 pi over 4, and then what's after 2?
3.
3. So 3 pi over 4. And then 4 pi over 4, and then 5 pi over 4, and then 6 pi over 4, 7 pi over 4. So now I'm going to reduce. So here it stays the same, so I'm just going to circle it. Here 2 pi over 4 is just pi over 2, right? But we already knew that. And then 3 pi over 4 stays the same. 4 pi over 4 reduces to pi, 4 over 4. And then 5 pi over 4 cannot be reduced, stays like that. And then 6 pi over 4 reduces to 3 pi over 2, but we already have it. Okay, did I give you a new unit circle? Not yet? Okay.
I thought we have already done this.
I know, but
She's reviewing.
yes, because you guys went on a big break. Yes, I'm gonna give you guys another one.
Yeah. Oh.
It wasn't big enough? Okay, so as I pass this to you, please write the ones that are circled, okay? Write them on your paper. And you have two types of lines, a solid and a dashed line. Just pick one of those. One is for degrees, the other one is for radians. Don't use the coordinates. Leave that blank for next class. Okay, you're only going to use the first circle. I'll tell you what the second circle is for in a minute. Okay, so you all got one, right? Yeah? Okay, now let's move on to the next one, which is going to be the was I recording the last part?
No.
I don't remember. Okay, so make sure you guys do this. And then if we were to put them all together, then you will see that you end up with the circle that we have here. Okay, now let's talk about revolution. So not as a war revolution, but as a turn, exactly. So you guys have seen in your car, on your dashboard, there's a little thing that says RPM, correct? Yes? Yeah? Have you ever thought of what R stands for? Revolution. It's actually revolution. But yes, it's actually a rotation, that's what it means. And then if you notice, the numbers go like from 0 to 1, 2, 3, 4, 5, blah, 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 right? I don't know how high they get. But when you see that you're going at 5 revolutions per minute, it doesn't mean 5. It actually means 5,000. Because there's times 1,000 on your dashboard. You should look at it when you get there. So every revolution is a complete rotation or a complete turn of a circle. So 1 full revolution in radians is equal to what? You can see it from the slide. First circle right there. 1 revolution, top left corner, 2 pi radians. You already knew that, right? So what about half revolution? What would that be in radians? 180 degrees, but in radians? Pi radians. What about a quarter revolution? You could see it there? Pi over 2, not pi 2, pi over 2 radians. What about 3/4 of a revolution? 3 pi over 2, very good. So, the way to convert from revolution to radians, oh, this looks very ugly. So from revolution to radians, you multiply by 2 pi. Now, if we want a revolution converted to degrees, what should we multiply it by? Not 2 pi, but what is equivalent to 2 pi in degrees?
90.
No, 360, a whole circle. Come on, guys. I don't want to send you back to elementary. A whole circle has 360.
That's the calculator.
Okay, now let's fill it ahead and position those angles on the Cartesian plane here. So, do you guys remember what standard position means?
Vertex, that's the
Vertex.
origin.
Or, yeah.
And?
And the initial
Positive.
is on the X positive.
Okay, very good. So vertex at origin, write it down. And initial side is the positive x-axis. Okay, so pi over 4, it's very easy, right? We already know where that is. It's half of pi over 2. So initial side, terminal side, and we get the direction of the angle. So that's theta. Now 5 pi over 4, do you guys remember how many radians are in half of the circle? The full circle is 2 pi, and half the circle is?
Pi.
Pi. What is pi if I divide it in 4s? It will be 4 pi over 4, right? So if this 5 pi over 4, we convert it into a mixed fraction, it will be like 4 pi over 4 plus 1 more fourth, right? 1 more pi over 4. So we're going to do the following. We know this one is half the circle, because it's pi. And then we still need to go past pi over 4. So it will be right there. So that is alpha. Okay, next angle, if you guys notice, is negative. So we need to go in the other direction. Clockwise, correct. But still, vertex at the origin, standard position, positive x-axis. So if we go 3 pi over 4, what would happen if we go like the whole half circle? What would that be? Negative? If I was to go here, that would be negative pi. Or negative 4 pi over 4, right? But we want a little less than that. So what should I go?
1 down.
A little back, right? Like pi over 4 less.
So 1 to
So right there. And this one is negative because it's going clockwise.
That's the same thing as 5 pi over 4.
Yes, and that's actually amazing that you made that discovery because all the trigonometric ratios are going to be the same for both angles. Yeah. So the sine, cosine, tangent, yes, because they have the same terminal side. Now here, for 9 pi over 4, will that be less than a circle or more than a circle? More, right? Because in fourths, 2 pi, and I know that like this is why it says so much since you guys are freshmen to get used to fractions because of things like this. So 2 pi is equal to 8 pi over 4. Yes, do we agree? But we need 1 more pi over 4. So then we're going to do a complete turn and then 1 more pi over 4. So that will be, this is gamma, the one that I was telling you. It looks like a Y.
Yeah.
Looks like
Okay.
gamma rays are actually very bad for your skin.
Actually, what?
Bad for your skin. To give you cancer. Okay, and then Jeremy. Actually, Jerry, you answer this question, Jerry. What can you tell me about angle theta and gamma? The one in red and the one in black. Go ahead.
We have the same.
Yes. The same initial side and also the same terminal side. Beautiful. Yes. So what do we call them? They actually have a name. How do you call someone who works with you? Coworker. So angles theta and gamma are coterminal. Okay? Because they have the same terminal side. That's the whole thing. All right, so that's the circle that I told you. We already went over what was the homework going to be. Yeah. Why is this not working? Oh, there we go. Okay, back over here. I want you to write the following. I hear a lot of talking. Okay, so, and I told you already, but I want you to write it down. To convert from revolutions to an angle measure you will either multiply by 2 pi or if you want it in degrees, instead of 2 pi, what should you use? What's the equivalent of 2 pi in degrees? A full circle is 360. And so that's what we were doing earlier. What we didn't do, but we saw some examples. So one full turn of a circle is 1 revolution, and that is equivalent to 2 pi or 360. If we look at half of a revolution, if you multiply 1/2 times 2 pi, you end up with pi, which you know that's half of the circle, or 180. Let's look at a quarter revolution. So you already know that is 90 degrees, right? So if you multiply 1/4 times 360, you get 90. Or if you multiply 1/4 times 2 pi, you get pi over 2. So is that clear? Yeah? To go from revolution to degree. Now, once we get to the angular velocity that we're waiting for, it's very important that before we calculate that, we go from revolutions to degrees or radians first, okay? But we'll get to that in a minute. All right, coterminal angles. Do you guys write that down? Not yet? Okay, I'll give you some time. Morning again. Okay, so coterminal, just like your co-workers, like a co-sponsor, like a co-funder. So there are people who work together and they have similar characteristics. And so that's the deal with coterminal angles. They have the same initial because they're in standard position, so that's by default. And then the terminal one is also the same. And just like we did on the examples that I showed you that Jerry told us they have the same initial and same terminal. This one here, and which one? This one here, right? So just like that, we're going to find others for those particular angles here. So for what the key here is that to find them, we're going to either add or subtract. That's what the plus minus means, okay? You're going to add or subtract multiples of 2 pi or 360, depending what you're working with, degrees or radians. What does the K, this is the one for radians. What does the K mean? K could be an integer. So could K be positive? Could it be negative? Yes. Integers are both positive and negative. So for example, if here, look at this one here. If I say K equals 1, then we're either adding or subtracting 360. But if I say K equals 2, we're adding, what's 360 times 2?
Oh, 360 times 2?
What? You guys are...
720.
gone. 720, yes. What if k is -1? Then you will be adding,
Adding it.
yes, adding
Oh, right.
-360, yes.
Oh.
Subtraction is addition. There are only two operations, addition and multiplication.
Yeah.
So, right here for this angle, conveniently named 420,
Wait, what angle?
right here. I didn't make it up, it was there.
They're appealing to the millennials, miss.
Yes, they're trying to appeal to you guys. So, let's read the instructions first. We gotta find coterminal angles, but they have to be in standard position. And then what else? What does it say after standard position? Find a positive. Okay, so then to 420 degrees, we're going to add or subtract. Oh, and we also want it to be, sorry, less than 360. Sorry, my bad. So we need to subtract. So we subtract. So from 420 degrees, we subtract 360 degrees, and that will give us 60.
60.
So what that means is that this angle and this angle are coterminal. Now the next one is negative, and we want it to be positive. So should I subtract or should I add? Add. Let's add 360. No, it's a real two. Sorry. 240.
240.
Yeah. And so we have the pictures right there on the right side. The angle that was equivalent to 420, it goes a complete turn and then a little bit more. And then the angle that is coterminal will be just 60. So here the negative angle goes like that. 120 negative. And then in the positive direction, the same angle that will have the same terminal angle will be 240 positive. Okay. I don't know if we're gonna have time for our.
We can just stop here.
Yeah, no, not here.
You almost got it.
Not here. Okay, you guys solved that. Checkpoint 5. Okay, so 400. What is coterminal to 400?
40.
40. Okay.
40.
And how do you guys get that?
By subtracting 36.
Okay, very good. How about the other one?
You add 360.
Why do you guys
And you
add?
get 35.
Because you made a positive.
And you get?
225.
Okay, so that means that if we graph them, that will be in the same spot. Okay, now let's do the same but with radians. So remember, we're going to either add or subtract multiples of 2 pi. So here's 17 pi over 6. Roughly, will that be more than a circle or less than a circle? More, yes. Because 2 pi should be equivalent to 12 pi over 6. Yes? Because 12 divided by 6 is 2. So we know that's more than a circle, but we want our angle, coterminal angle, to be less than 2 pi and positive. So we're going to have to subtract 2 pi. Or in other words, we're subtracting, if we convert this 2 pi to 6 for the denominator, it will be 12 pi over 6. And that is 5 pi over 6. Now we have negative pi over 12. that's negative, we want to get to a positive angle. So we're going to add 2 pi. What will 2 pi be in terms of 12?
24 pi.
Oh, 24 pi.
24 pi over 12. Right, because this one has a 1, and we want it to have a 12, so we multiply top and bottom by 12. That's how we do it.
I get
You
it.
see why fractions are necessary? Okay, and then what happens here? 24 pi minus 1 pi. How many pi's do we have? 23 over 12. Is that more or less than a circle?
Wait, what?
A full circle will be 24 pi over 12 because that is
Oh,
2 pi. So this is less than a circle.
that's like 1 reach. Come on.
What time is it?
It's 47.
Okay, you guys can do this.
3 minutes? Let's take a look.
No, we don't have time because it takes time to set up out there. But for sure we'll do it.
Miss, for Friday, on March 14th, which falls on a Wednesday,
No.
we bring.
Isn't it a swimmer?
Oh, yeah. My birthday. And then my birthday is